Now, you can do this. You can do this little experiment at home. It's actually quite fun and makes a wonderful mess for your parents to clean up. Now, inside this blender, I have put some leaves from our red cabbage, and I've added to it distilled water. Now, you can use tap water for this, but it will throw it off a little bit if you're trying to make potions or, blow up your backyard or something. So, if you want to do it the correct way, use distilled water. If you just want to see the magic of science, regular tap water will work just as well. Now, all you need to do is mix this up, and it will release the anthocyanin into our mixture. And if we add acids or bases to this, we will get a change. We will get an observable change. Experiments, so we are doing experimentation, and we are using observation to figure out whether something is acidic or basic. It's really quite fun. All right, so I pour in it. What color do we get? Yes! I pour in it. What color do we get? Yes! So we now know that with an acid, we get a pink color. With a base, we get a green color. And we can do this for, hours, as long as you have enough space inside your jar. As long as you have enough space inside your jar. Now, these natural. Now, of course, in the Wizarding World, they've developed spells to do the exact same thing. So they don't do this very often anymore. But in the Muggle world, finding out whether something is acidic or basic is a huge part of their magic or science. To the point where they have come up with some rather amazing chemical versions of these same pH indicators. One of the ones I like the most is phenolphthalein. Phenolphthalein. Phenolphthalein is an acid-base indicator that only shows whether or not an acid is present. Shows only or not a base is present and not an acid. Because of this, you can do some fairly amazing things. Take our beautiful flowers here. Ah, yes. Now, inside this spray bottle, I have vinegar. Vinegar smells like sour salad dressing. And I can spray these flowers all day long, and nothing will happen. However, because they've been treated with the phenolphthalein, phenolphthalein, if I spray it with a base, they turn this beautiful shade of pink, or fuchsia, as my daughter calls it, with the unfortunate side effect that now these flowers smell like a dirty cat box. Yum! So, as you can see, Muggles do have science. And they do have the ability to tap into these natural forces that wizards tap into with wands and whatnot. Which brings us to that color change. Now, as I said, we are more similar than we are different because we are all humans. Now, to notice notice a distinct change in color, you have to have two things. Eyeballs and light. You see, we don't see objects. We see light bouncing off of objects. That's how our eyes work. As light bounces off an object, it comes through the cornea, hits our optic nerve, and at that point, now, in our Muggle Science experiment, we saw we saw a change in color. We did, with our eyes. And a wizard will see that color change the exact same way, because we are more alike than we are different. Humans are very odd in that, and how we choose to separate ourselves based upon tiny differences, rather than looking at the greater similarities that we all share. Wizards do it, muggles do it, and, well, there's no other way to look at it. It's foolishness. As human beings, we detect light and color the same ways. Air, light, you see, this is two changes in color. In the wizarding world, the color-changing charm, Colaveria, is used to change the color of objects, hair, and whatnot. And it's quite important. You see it used a lot in wizarding schools to help keep track of who's in the lead in the quest, and who's in the points lead for the quest for the house cup. However, as we've seen here, muggles have the ability to change colors as well, using different tools, in this case acids, bases, and red cabbage juice. But that change in color comes down to light. You see, be you muggle or be you wizard, you don't see objects. You're not seeing me right now. What you're seeing is a very bright light bouncing off of me. And the different colors that you see come down to the shape of the molecules that make up what that light is bouncing off of. When we added acids and bases to our red cabbage juice, we changed the shape of tiny molecules that we can't even see with the naked eye. As those molecules change shape, well, they reflected a different color of light. White light contains all the colors of the rainbow, and the shape of molecules dictates, well, what light is reflected back, what color light is reflected back, and what we see. Now, in the Muggle world, this is used for everything from traffic lights to fashion or makeup or whatever you happen to play with to change the colors of things. In the wizarding world, this use of light, the manipulation of light, is used for all sorts of things. Now, such as invisibility, such as the dreaded invisibility cloak. Now, inside this jar, and muggles are quite adept at changing the color of things as well, which is what I want to talk about you next. Now, muggles make these things called jelly marbles. Now, these hard little plastic beads are what a jelly marble looks like before you engorge it. Oh, yes, they can engorge things as well. Yes. Now, what we saw inside our Muggle experiment with red cabbage juice, the active ingredient in cat pee, ammonia, and vinegar, the active ingredient in delicious salad dressing, we saw a change in color. Now, changes in color are part and parcel of the Wizarding world and the Muggle world. Who doesn't love a little color in their life? Who doesn't love a little bit of color in their life? Oh, you know that I do. Now, ask a wizard why color. And here's an area where Muggles have taken things much further than wizards have. To a wizard, a change in color is a thing of magic. It changes color, and that's all you need to know. Muggles are incredibly inquisitive, and they took it much, much further. They wanted to understand why we see colors and how we see colors, and it comes down to our eyes. And those eyes can be a muggle eye or a wizard eye, muggle eyes or wizard eyes. No matter what, we have the same eyes and we react to light in the same way. Now, muggles have figured out that when photons, tiny, when light photons hit your eye, it passes through the transparent cornea and then refracts like light in a prism, and focuses the light onto your retina, where the light is selectively detected and absorbed by special photoreceptor cells, the rods and the cones that make up that allow us to detect color with our eyeballs. And Muggles have found some really fascinating things that they're trying to do with light. Take television or the electric light bulb. Fabulous thing invented by the Muggles, the electric light bulb, and something that's used in Muggle and wizard houses, because who wants to sit in the dark all the time? Yes. Now, light has some fairly amazing and magical. It has some fairly amazing and, well, somewhat magical properties. And Muggles have found all sorts of interesting ways to use this or to have fun with this. One of the ways is with jelly marbles. One of the ways that I like to play with light is with jelly marbles. Now, these are jelly marbles, these tiny little hard, small beads. They're all of about that big, so teeny, tiny little things. But these polymers, long chains of molecules hooked together, have an amazing ability to soak up liquid and retain the properties of the liquid that they soak up. Now, I have pre-soaked some beads in Mountain Dew, that wondrous sugary green concoction made by Muggles to rot teeth and make them look British. Now, as you can see, there's a slight yellow sheen to these. However, since white light contains all the colors of the spectrum, these marbles react to a special kind of light. Now, this is a black light. This is light that's on the wavelength of. This is what's called a black light. Again, one of the colors that are inside all light. And if you shine this on something, well, these jelly marbles filled with Mountain Dew, they remind you exactly why you probably shouldn't drink Mountain Dew. That doesn't look healthy, but it's fairly amazing how bright that gets. And again, this happens because our eyes work the same, because Muggle eyes work the same as wizarding eyes. Muggles are just a bit more diligent in, well, looking past what they can see and trying to figure out how everything actually works. Now, one of the most famous artifacts in the wizarding world is the Cloak of Invisibility. Now, invisibility comes down, again, to light. For us to make something invisible, we have to basically camouflage it from our own eyes. We need to make it so that the light that we're seeing, so that the object, the invisibility cloak in this case, redirects light or changes that light to the same wavelength as the light around the person wearing the cloak. Muggles are working on their own version of this. Now, jelly marbles can allow this to happen as well. These jelly marbles have been soaked in just regular water. Water from the tap, like, well, water you'd find at home. Now I pour those into here, and because they retain the properties of the water that they've been engorged with, light will react the same to these jelly marbles as they would, well, to the water I'm about to pour in here. Now, as I pour the water in, you'll note that they become invisible. That's because our eyes and how we see things are based upon light. This is a universal aspect of being human, and Muggles and wizards are humans. I cannot say that enough. In fact, you'll probably think I've said it about 10 times, about 100 times, probably 10 times too many by the end of this program. Now, those jelly marbles that we use to create invisibility and to create our glowing Mountain Dew balls come from a branch of Muggle science called chemistry. And chemistry is probably one of the closest examples of, well, a branch of study of wizardry that correlates with a branch of study in Muggle science. Now, in any potion-making class at any school of witchcraft and wizardry, there are certain things that, well, happen and certain tools that need to be used. It could be a cauldron, most likely a magic wand, and some form of magic ingredient that gives the potion its, well, magical properties or its chemical properties. So, now inside a Muggle chemistry class, there are certain tools, beakers, Erlenmeyer flasks, test tubes, wands for stirring, Bunsen burners, and all sorts of other tools used by Muggles to create their own potions or chemical mixtures. And in a Muggle chemical mixture, the magic ingredient is called a catalyst. A catalyst in the Muggle world is any substance that increases the speed of a chemical reaction without itself being fundamentally changed during that chemical reaction. And Muggles have been using these things, have been using these chemical reactions for hundreds of years to make the thing from soap to, well, to try and rip people off and convince them that they could do magic. Now, one of the oldest folk tales and fairy tales in the Muggle world and the magical world is the story of the genie and the lamp. Now, we all know this story. There once was a young boy who found a filthy bottle in a pile of dragon poop. And he began to wipe it off on his shirt. And as he wiped it off on his shirt, the bottle began to get very, very hot. And he popped open the lid and set it down and stepped away. And then a cloud of smoke and steam appeared, and out of that smoke and steam came a genie who said, "You have opened the lamp. You may make 3 wishes. I will grant you 3 wishes." Now, in the wizarding world, if you rub on a genie's lamp, an actual genie will come out, and you really don't want to meet one. They're not very nice at all. In the wizarding world, in the Muggle Science world, what we just did is, well, what's called an exothermic or heat-producing reaction. And that is, well, really not much different from making a potion. Now, this one was made using H2O2, or hydrogen peroxide. You probably have hydrogen peroxide at home. Your mom and dad might have put it on, well, if you've gotten a cut or an owie. It's that stuff that bubbles up when it hits. Now, the stuff we're using here is much, much stronger. The stuff you have at home is 3% hydrogen peroxide. This is 35% hydrogen peroxide. So if you get it on your skin, it literally will take your skin off. So if you decide to do this at home, I recommend not using this. The other thing that's being used is magnesium dioxide, this black powder right here. Now, magnesium dioxide has been used by Muggle potters. No, not those potters. These potters are more of a profession, people that make pottery, to create a glaze on their pottery so that when you eat it, it doesn't dissolve or get mud in your food. And according to legend, unscrupulous potters, again, not those potters, but people that make pottery, used this chemical reaction to, well, fool people into thinking that they could buy a magic genie's lamp. Now, we're going to do that reaction one more time. But we're going to do it inside this 2-liter bottle. Now, if you pay close attention to the bottle, something amazing is going to take place. Are you ready? All right, let me head over here and see if I can't catch myself on fire. As you can see, that 2-liter bottle is shrunk down by about 1/3. That's because the chemical reaction, the chemical mixture that we put inside that bottle is an exothermic or heat-producing reaction. And much like our jelly marbles, plastic is made of long chains of molecules hooked together to create polymers. And there's space in between where those molecules are hooked together. And as the bottle heats up, due to the magic or science of Muggle chemists, due to the wondrous wizardry of Muggle science, the bottle actually shrinks down to 1/3 of its size. Now, you can't tell me that isn't magical, right? But Muggles have gone even further with this, and wizards, but Muggles have taken this even further. One of the most famous Muggle chemical reactions is called elephant's toothpaste. It's called elephant's toothpaste. And again, it involves H2O2, hydrogen peroxide, but this time, instead of magnesium dioxide, we're going to be using potassium iodide as our catalyst. And what this does is it breaks apart the bonds that hold the hydrogen and oxygen together and leaves behind plain water. Now, elephant's toothpaste can be done several ways at home. You can make it, the safest way for you to try this at home is with yeast, water, and soap. You can look it up online, or you can always go ahead and message me and I will gladly send you directions. But that's a very slow exothermic reaction. We want a very fast one, and a very big one. So, we're going to use this bad boy. Ah, yes! Now in here I have just about 100 milliliters of hydrogen peroxide. Inside this cylinder, I have potassium iodide. I have a supersaturated solution of potassium iodide mixed with water. Now, a supersaturated solution basically means if I were to add more potassium iodide to it, it would just sink to the bottom and kind of float there, still as potassium iodide. It would not dissolve. So there's a lot of potassium iodide inside this mixture. Now, I'm going to add some soap to this so we can capture the gases that are released, and when we create our elephant's toothpaste. And I think we'll add some color to it as well. Amazing, isn't it? Now, wizards have been doing along the same lines for quite some time. Now, wizards, using, well, of course, magical ingredients, have been doing the same sort of thing for quite some time. The most usually around Halloween. Yes, there's a tradition in the wizarding world of making pumpkins puke, which is what we're going to do right now. Now, in the wizarding world, when we do this, when this reaction is done, there's usually a rhyme that goes along with it about a wizard named Peter. Peter, pumpkin eater, had a wife and couldn't keep her. Put her in a pumpkin shell, she did not like that very well. She was tall, that pumpkin tiny, and pumpkin guts are cold and slimy. So she made a potion and mixed it twice, said magic words that weren't too nice. She poured that potion on the floor, that pumpkin puked her out the door. Out the door. couldn't keep her. Put her in a pumpkin shell. She did not like that very well. She was tall, a pumpkin time. It's a cold and slimy. She twice swirled it twice, said magic words that weren't too nice. She poured that pumpkin, pumpkin puked her out the door. And in that vomit Peter fell. And in that vomit Wizard Peter fell. He did not like that very well. So, as you can see, Muggles have been doing science, wizards have been doing magic, but there are those amazing parallels that tie the two groups together. But I know what you're thinking at home. That's great, Professor Nice, but what about actual spells? Can Muggles emulate actual spells? Not biology, not chemistry, not potions, not herbology, actual spells. And to you I say, well, yeah, they can. Sort of. Take the Wingardium Leviosa spell. Now, the Wingardium Leviosa spell was the first attempt by Muggles to by wizards to learn how to fly. Was the first attempt by wizards to learn how to fly. One of the universal conditions of being a human being is that when you first see a bird fly, or in the Muggle world, an airplane fly, you think, I wish I could fly. And wizards were no less desirous of that than, well, Muggles were. Granted, wizards figured it out a little bit earlier, but they did so thanks to Muggles. You see, back in the 1700s, there was a wizard named Ibn al-Ajir, who lived in what is now modern-day Spain. And he created the Wingardium Leviosa spell. And he called together every wizard within 100 miles to come see him prove that a wizard could fly.
Put all your information in here for your description. Select what you are streaming and your game title you can type in here. Now you can select your any stream, but because we set to